Okay, Ms. Whitaker here, and I'm going to go over the notes for solving systems of equations by elimination using multiplication. Now, we've already talked about eliminating using adding or subtracting or doing the opposite signs of one of the equations to cancel out or eliminate one of the variables. Today we're talking about eliminating one of the variables, but we have to tweak one of the equations or maybe sometimes both equations, and we have to multiply this time by the same number all the way across to be able to do that. So looking at your notes, the first bullet says some systems cannot be solved simply by combining the equations because opposites already exist. So sometimes we're not able just to combine or tweak or change the signs of one of the equations. So sometimes we have to do a little bit more. That's what we're going to do today. The second bullet says one or both equations must first be multiplied by a number before the equations are added to create the opposites. And then remember, there are many forms of multiplication that can be used to create opposites. So let's start with the first example. I've written the first example up here on the board. So if you'll just follow along with me. Now we look at both of these equations, and if we use the same method that we were doing before, we notice that there's not anything that can be eliminated in their current state, and we can't just change the signs of one of the equations to help that along. So we've got to multiply one or both of these equations to be able to eliminate a variable. Now I'm looking at my y's right here, and I notice that if I just multiply the top equation by 2, then I'll have a negative 4y, and I would be able to cancel out my y's or eliminate my y's. So that's what I'm going to do. So I'm going to basically multiply this entire equation by positive 2. And that's going to give me, and I'm going to rewrite it down here, it's going to give me 6x minus 4y is equal to, and then 2 times 19 will be 38. And then I'm going to rewrite the second equation because now I'm able to eliminate. So what I get is I'm going to eliminate my y's. I'm going to now combine these, and I get 11x on the left, and I get 55 on the right. So that gives me x is equal to 5. So there's one of my variables solved for. Now I can just take that x and bring it back to one of my, or both, of my original equations to plug in for x to get my y variable. So I'm going to rewrite over here 3 times 5 now for x minus 2y is equal to 19. So that's 15 minus 2y is equal to 19. I'm going to subtract 15 from both sides, and I get a negative 2y is equal to 4. Y is equal to a negative 2. So then my answer will be 5, negative 2, and that's my solution to the system. Now at that point it looks very similar to what we were doing before. We just had to tweak one of the equations for this case to be able to eliminate one of our variables. All right, number 2. Once I look at this, I see if I can combine any of these equations to see if I can eliminate any of the variables. And I see in the current state that I cannot, so I can't just change the signs of one of the equations like I did before. So I'm going to have to tweak this by multiplying one of the equations by a number. And I'm just going to, I could eliminate either one of these, x's or y's, by multiplying by a negative 2. So I'm just going to multiply by a negative 2 on the bottom here. So I'm going to rewrite the top. 2x plus y is equal to 4, and then rewrite this second equation. Negative 2x minus 4y. Remember that negative 2 is multiplied to everything in the equation equals a negative 28. All right, so now I can eliminate my x's. Those are gone. So now I have a plus y and a minus 4y, so that gives me a negative 3y, and a positive 4 and a negative 28 gives me a negative 24. So that means y is equal to 8. So there's one of my variables. I just need to plug it back in up into one of my original equations. So 2x plus 8 is equal to 4. 2x is equal to negative 4. X is equal to a negative 2. So x is equal to negative 2, so my solution will be a negative 2, 8. All right, so next let's do a couple more examples. All right, number 3, I notice that I cannot eliminate a variable as they are, and I also can't just change the signs of one of the equations to eliminate a variable, so I'm going to have to multiply one of the equations or both of the equations by something to be able to eliminate. And I look at the numbers and I'm thinking that the easiest thing to do would be to multiply the first equation by a negative 3, and that'll give me a positive 15, and that will cancel out my y's. So that's what I'm going to do to this one. I'm going to rewrite down here, and I get a negative 33x. Make sure all your signs are correct. I'm multiplying everything by that negative 3. So negative 3 times a negative 5 is a positive 15y, and then a negative 3 times 80 is a negative 240. And then I'm going to rewrite the second equation. And now I can eliminate my y's. So that leaves me with a negative 24x on the left and leaves me with a negative 120 on the right. And that gives me x is equal to 5. So negative 24 times 5 is a negative 120. All right, so now that I have my x, I can go back to my original and plug in for x. So 11 times 5 minus 5y is equal to 80. That's 55 minus 5y is equal to 80. And then I end up with negative 5y is equal to, what is that, 25? So y is equal to a negative 5. So I should have 5, negative 5 for my answer for number 3. So again, I just had to tweak one of the equations. I had to multiply it all the way across to get that answer. All right, and number 4, once again, I cannot eliminate a variable as they are. I cannot change the signs of just one of the equations to eliminate a variable, so I'm going to have to multiply. And there's different ways you could do it. It really doesn't matter as long as you're able to eliminate a variable. What I'm going to do is just looking at the equations, I'm going to cancel out my y's, so that means I have to multiply everything by a negative 3. So I'm going to rewrite the top. And now rewrite the bottom, everything multiplied by negative 3. And then those y's will cancel out. That leaves me with a negative 5x and leaves me with a negative 10x is equal to 2. Now I'm going to plug into the original to solve for my y. And y should be equal to a negative 5. So my solution is to negative 5. All right, number 5 is a special case because I can't eliminate the way they are, and I can't change the signs of the way they are, and I cannot see an easy way to multiply just one of the equations to eliminate a variable. In this case, I'm going to have to multiply both equations by a number to get to that point where I can eliminate one of the variables. So I'm looking at, I can do either one of these variables. The y's have lower numbers, so let's just deal with the y's. Now what I really want to do is multiply them by a number to reach the common multiple of 3 and 2, which is 6. So if I can get to get a 6y and a negative 6y, that's what I'm going to do. And for the first equation, I'll just make it multiply that by 2. So let's just multiply this by 2 and see what we end up with. So I'm going to rewrite down here. We get 8x minus 6y is equal to 24. Now, I need a positive 6y now for the second equation. So that means I'm going to have to multiply that negative 2 by a negative 3. So that whole equation needs to be multiplied by a negative 3. Now remember, I'm not really changing the equation. I'm making it equivalent equation that means or represents the same thing if I multiply everything by that same number. So I end up with a negative 9x, and now I end up with a positive 6y equals a negative 12. Now I can eliminate those y's. I end up with a negative 1x, and then on the right, I will end up with 12. So I got to get rid of that negative x, so I'm going to divide by negative 1 on both sides, and I end up with x is a negative 12. Now I can plug it into the original equation and solve for my y. 4 times a negative 12 minus 3y equals 12. That's going to be a negative 48. Add 48 to both sides. So y is going to be equal to a negative 20. So then I have my x and I have my y. My solution is going to be a negative 12, negative 20. So that is a special case where I had to multiply something to each equation in order to cancel out or eliminate one of the variables. It does not have to be the same number, obviously, but you do have to multiply that number all the way across that one equation. I'm just making an equivalent equation that allows me to eliminate the variables, and in this case, I am creating equivalent equations for both equations to cancel out or eliminate one of the variables. All right, in number 6, same thing. Cannot eliminate. I cannot just change the signs. I'm going to have to multiply, and that's not going to be easy. I can't just multiply one of the equations by a number to eliminate a variable easily. Now, I could do that. I could just multiply a fraction by one of the equations to be able to eliminate, but instead of using fractions, I thought we'll just go ahead and multiply both equations by numbers that we can get to a point where we can eliminate. So instead of using fractions, you can do that if you want, and you can look up Khan Academy. It'll show you how to do that. But let's just sticking with whole numbers and working with both equations. So number 6, I'm going to stick with the x's because they have the lower numbers. So I see that I can get to 12, 3 and 4, common multiple of 12, the least common multiple. So one of them I need to be a positive 12, one I need to be a negative 12. So what I'm going to do is on the first equation, I'm just going to multiply everything by 4. And then everything on the second equation, I'm going to multiply by a negative 3. And that will give me my 12x and then my negative 12x, so I can eliminate my x's. So let's rewrite them. So that's the first equation rewritten, everything multiplied by 4. And then the second equation is going to be a negative 12x, so I can eliminate, plus 15y is equal to a negative 18. So now I can eliminate my x's. That leaves me with a negative 32y plus 15y is a negative 17y is equal to 34. So that gives me y is equal to a negative 2. So I'm halfway there. Just need to plug that right back into one of the equations up top. It's going to give me a positive 16. But then I'm going to subtract 16 from both sides. So 3x is equal to a negative 3. X is equal to a negative 1. So negative 1, negative 2 is my solution. All right, to number 7, once again, I cannot eliminate anything the way they are. I can't just change the signs of one of them, and I can't just multiply a number by one of the equations unless I want to use fractions, but I don't. So I'm going to multiply to get multiply both equations by a number, different numbers, so I can eliminate. Now, 4 and 6 are lower numbers, so those are the ones I'm going to deal with. Now I could do 7 and 5. It doesn't really matter, as long as I just multiply that equation by the same number. So I'm trying to get to 12. 4 and 6 have a common multiple of 12. So I want to make one a positive 12. Okay, and then I need to make the other one a negative 12. So first thing I'm going to do is multiply this first equation by 3. I'm going to rewrite down here at the bottom, and I'm also going to go ahead and multiply the bottom by a negative 2. So let's rewrite those equations, multiplying out 12x 12x plus 21y is equal to 18. And then the bottom one is going to be a negative 12x minus 10y is equal to a negative 40. Now I can cancel out my x's, and I end up with an 11y on the bottom. And I end up with a negative 22 on the bottom, or 11y on the left, a negative 22 on the right. So y is equal to a negative 2. Plug that into the original. And then solve for my x. X is equal to 5. So 5, negative 2 is my solution. Again, I just had to tweak both equations to reach a point where I could eliminate one of the variables. Okay, last question. All right, for this last one, I'm not going to go through the whole thing. I will tell you that I multiplied the first one by 5, and the second one I multiplied by a negative 2. So I could cancel out my x's, and I end up with a solution of 4, 2. So do that on your own, and see if you get that answer. And then work on your homework for practice and have that done by tomorrow. Thanks, and I missed you today.